All right, now we're going to move on to something slightly new. Here we have dy dx equals some function of y. No x's right now, we're just dealing with y's, no more complicated second derivatives, but we've got a y here. Now, the problem is that when I do an integral, I'm going to do the integral of this in respect to x, and I don't know what it is in respect to x. So what I'm going to do, um, there's two approaches. The book, and they're effectively the same. The book says flip this around and flip this around. So dx dy equals 1 over the function of y. Sorry, that's a y. And then you can just do your integral. So you can say x equals the integral of 1 over dy. So right there. I like to do it the same, but I rearrange it. I say I want to divide both sides by this g of y. So I have 1 over g of y dy dx equals 1. And then when I integrate this, I think about integral of 1 over g of y dy dx dx, and I think that these cancelling. Now, it's not strictly speaking true what happening. Now I've got the integral of 1 dx. So I'm effectively I'm still doing the same thing. I'm integrating the 1 over g of y in respect to y. It's just how I think about it slightly different. So this one here, I've done it nice and easy. I want to move this across to the side. I need to have a times over y, or I can divide by 1 over y. Either way, I end up with y dy dx equals 1. Then I do my integral. So the integral of this is going to be y squared over 2. That's going to be x. Now, the thing is, we usually want to write this in terms of what y equals. So we're going to just do some rearranging now. Times by 2, plus c. Times by 2, y squared equals 2x plus 2c. And then do a square root. And depending on the circumstance, you might have a plus or minus. Yeah. You can always, often you'll find when you're doing these sort of problems, you want to sub in at the end and go 2c is just a variable, it's a constant, just a constant, and I could replace that with a different constant called k or something like that rather than have 2c there, but I'm happy with that for now. So let's look at a slightly more difficult one. So here, again, I want to move this across this side, and so I'm going to 1 over 2y plus 1 dy dx equals 1. You always want to divide by this. You do not want to minus it off. That's going to cause you problems. So the integral of 1 over 2y plus 1 dy is integral of 1 dx, just x. Now remembering here, this is going to be a log, so ln of 2y plus 1. But if we remember our the exact values, remember our rule about how to do this, I'll need a half out. There's a little formula, plus c. Now this one's a little bit more messy to rearrange. In fact, I might just do the plus c here. It doesn't matter which side I put it on. It's one less step. A little more messy, but we can rearrange this. Now I need e to the both sides, so this is going to be 2y plus 1 equals e to the 2x plus 2c. And then minusing 1, y equals e to the 2x plus 2c minus 1, divide by 2, and I got my solution. However, we often write this as a e to the 2x minus 1 over 2, where a equals e to the 2c. Using our